Alright, today we're looking at section 2.6, radical equations. Once again, recording from home, you may hear sounds, strange noises. I apologize in advance. We're going to learn about solving radical equations and solving equations with positive rational exponents. So a method for solving radical equations, we begin by isolating the radical expression on one side of the equation. If there's more than one radical expression, then choose one to isolate. Raise both sides of the equation to the power necessary to undo the isolated radical. If any radical expressions remain, repeat the previous steps. We simplify and solve the equation, and we check our answers. Clearing radicals often adds extraneous roots, in other words, roots that weren't there. And you can get a situation where all the roots work, none of the roots work, some of the roots work. You need to check them all. For us, we only have to do this process once usually. There are other problems. I don't think you'll count them in your homework, but you may have seen them before, where you'll have to clear the radical multiple times, or different radicals. You'll have to do this multiple times. All right, so first we have our first exercise here. We have the square root of 9 minus x minus 3 equals x, and we must solve this equation for x. First thing we want to do is get the radical by itself. It's already on the left-hand side, so we'll leave it over there. So we get 9 minus x. And then we'll say that equals, and I'll move this 3 to the other side, so it becomes a positive 3, x plus 3. Now looking at this, we see that we want to get rid of this radical. It's a square root, so I'm going to square both sides. Now, in doing this, I may end up creating a root that didn't exist before. We'll talk more about that in a moment. So I'm going to square both sides, and I'm going to get 9 minus x equals, and I'm squaring this out. So remember, I have to multiply this by another. So this is essentially like saying x plus 3 times x plus 3. And I'm going to write that here. So I need to FOIL that out. So when I FOIL that out, I'm going to get x times x is x squared. And then x times 3 is 3x, and 3 times x is 3x, so that's plus 6x. And then I'm going to have 3 times 3, which is 9. It's plus 9. So I've FOILed it out. You just don't square each term, otherwise you'll miss the 6x in the middle. Now that we have that, we're going to say that equals, and I'm going to subtract 9 from both sides. My 9 goes away there. It's fine. X squared plus 6x. My 9's cancel here. I'm going to add x to both sides. Oops. So doing so, I get 0 equals x squared plus 7x. Now this is a quadratic, so we set it equal to 0 and solve. It already has 0 on one side. Excuse me, my focus is going everywhere. And so with that in mind, all I have to do is factor out the greatest common factor. You don't need to undo FOIL, just because it already has a greatest common factor. And then we get two linear factors here. So I have a situation where x can equal 0, or x plus 7 can equal 0, or that means x equals negative 7. So now we go over here and we check. First we're going to check x equals 0. So we check it to the original equation. And checking it to the original equation, we'll get the square root of 9 minus 0 minus 3 equals 0. So the square root of 9 is 3. Remember, when we take the principal square root, we get the positive square root, in this case positive 3. Minus 3 equals 0. That checks out. I'm going to do the other one in different colors so you can tell. And then we're going to also check x equals negative 7. So when we plug in negative 7, we're going to get the square root of 9 minus a negative 7 minus 3 equals negative 7. So that's going to give us the square root of 16 minus 3 equals negative 7. And already you can see there's going to be a problem, because what's going to happen here is I'm going to have 4 minus 3 equals negative 7. That means 1 equals negative 7. That's not true. So this one doesn't check out. So x equals 0 is our only solution. Now I know some students, we try to give you nice problems in your homework, on your test, and when we do that, sometimes students will notice a pattern, like the lowest number works, or the highest number works. Maybe the number that's always negative works, or maybe the number that's negative never works. And when you notice these patterns in your homework, they're just patterns that come up because we give you nice problems. It could easily be switched, if we change the sign in front of something, like if, you know, this was maybe a plus x instead of a minus x. It could do something like that to where we could have changed it to where one of the answers, the other smaller or larger answer worked or didn't work, vice versa. So watch out for that. Watch following into patterns. But very important you check these. So next we have the following equation. We do it like we did the other one before. I'm going to move this x to the other side. So I'm going to get the square root of 109. So I'm going to solve the equation for x for the square root of 109 plus 29x quantity minus x equals 11. We have plus 29x, and that's going to be equal to x plus 11. Once again, I want to square both sides to get rid of that square root. And squaring it, remember we're going to have to multiply x plus 11, thank you, times x plus 11. Foil that out, just as a note. And so, when we do that, we're going to get 109 plus 29x, and that's going to give us equal to x squared, x times 11, and 11 times x will give me 22x. Hopefully everyone can see that. If you have questions of where that 22 came from, please email me, ask me. I'll be happy to answer your questions. And then 11 squared is going to be 121. Now we get everything to one side and solve, so I'm going to be adding, let's say, actually subtracting 109 from both sides here. I'm also going to be subtracting 29x. So I'm going to get x squared, 0 over here. So that's going to give me minus 29x. So that's going to be that's going to be 7, negative 7x. And that's going to be 9, 16. That's what? It's going to be, now that I'm thinking about it, I can't do it in my head. Plus 12. So I'm going to factor this. I need two factors of 12 whose different, or whose sum is negative 7. So x minus 4 and x minus 3 will do that. So I have my answers as x equals 4 or 3. And you can see how I just set each of these factors equal to 0 and quickly did that in my head. When you have these nice linear factors, your leading coefficient is 1 in front of your linear factors. Usually you just have to change the sign in front of the constant term to get your solutions, your roots. So we need to go back and check these. So let's check them. And so we're going to check them in the original equation. So I'm going to check x equals 4. So I'm going to get the square root of 109 plus 29 times 4 minus 4. Excuse me, I think I have a little one. Let's pause it. Coming up the stairs. Equals 11. And so now that we have that, we're going to get the square root of 109 plus, and then 4 times 29. 4 times 30 would be 120. So that means one short of that would be 116 minus 4 equals 11. So that's going to be the square root of 9 plus 16 is 25. So it would be 225 minus 4 equals 11. So that means the square root of 225 is 15 minus 4 is 11. That checks out. Then we have to check the next one. See if we have enough room to do this here. X equals 3. And so it's going to give us the square root of 109. And then we're going to have plus 29. That's 3. People are mowing the yard. Equals 11. So we have minus 3 equals 11. So I'm going to have square root, and 3 times 29, 3 times 30 is 90, and then minus that would be minus 3 from that would be 87. So 109 plus 87. You need to use your calculator to do this. It's fine. You can do that. And then I'm going to have 7 plus 9, which is going to be 6. Carry the 1. That's going to be 9. So it would be 196 minus 3 equals 11. So that means we're going to get the square root of 196 is actually 14 minus 3 equals 11. And that checks out. 11, thank you. Alright, so both of them checked out. Both of them worked. We get to keep both answers. That's excellent. So like I said, in these exercises, you could get one answer that works, no answer works. Some answers work. Alright, so rational exponents. So if we remember, if we have x to the m over n, this is kind of hard to see, but that's an exponent. It'd be easier to see if it was written a little bit bigger. And so x to the m over n is the nth root of x to the m, or the nth root of x all raised to the m power. They're interchangeable. This means we can solve the equation that contains the rational exponent in the same way we solve a radical equation, which we just raise to whatever side of power we need to undo that radical. And so this one's pretty straightforward. What we need to do, we have a fifth root here, so all we need to do on both sides here is raise this to the fifth power. And so I don't need to FOIL anything out because they're both raised to the fifth power. So all I need to do is say this is 2y minus 3 squared, because that 2 is still there. 5's cancel. 5's cancel here. That's going to equal 3y. So I have to FOIL this out. So I'm going to have, you want to write it off to the side. Let's just write it out this time. My leading coefficient's not 1. So 2y times 2y is 4y squared. 2y times negative 3 is 6y. 2y times negative 3 again, 6 and negative 6y. So I have negative 6y for negative 12y. And then we have negative 3 times negative 3, which is going to give me positive 9 equals 3y. Move the 3y over to the other side. I get 4y squared minus 15y plus 9 equals 0. So now we see if this factors. So I need factors of 9 and 4 whose sum is negative 15. So I already know that 2 and 3 are not going to be the pairs I want to use because I got that, and that was negative 12y in the middle to begin with. So if we change the middle term, if it still factors, I'm going to have to go with something else. Anything with 9 in it may or may not work. I'm thinking it won't work because 4 times 9 is too big, and they need to have the same sign. So I'm thinking 3's are going to be necessary still. Still going to need 3 here. They're both going to have to be negative. I'm going to need a y here and a y here. But this 4, I'm pretty sure what's going to happen here is this is going to be 4 and this is going to be 1. And the reason why I rationalize this out without making a big chart is because I know that I can't have 2's here, because if I did, I'd get this polynomial right here, and we said we already changed that. So I need to change one of these factors. I chose to do the 4 times the 1 to give me 4y squared first. And I'm going to get 4y times negative 3, which is negative 12y, and then minus 3y is going to give me negative 15y. So that's looking ahead to the problem. There's a 1 right here. That's a 1. Anyway. To solve this. So once again, I'm going to set each of these factors equal to 0 and solve. So I'm going to have 4y minus 3 equals 0. And once again, if you're having trouble factoring, please contact me. I'll be happy to go through it with you. And I get 3/4 for one of my answers, and then for the other one, I'm going to get y equals 3. So we still want to check these. Now, one of the things that led us into problems before is that we had even roots, and even roots give interesting parts because when we square them out, stuff that wasn't allowed to be plugged in for x is now allowed because we squared it out. We could have gotten negative under the radical or something like that, or a even radical equal to a negative number. Here, these can be equal to negative numbers, no problem. But you still need to check. So we'll check the nice whole number 3 real quick, and we'll say 2 to the third. Sorry, not 2 times 3, excuse me. Minus 3 to the 2/5 equals 3 times 3 to the 1/5. So now that I have that, I'm going to say this is going to be 6 minus 3 to the 2/5 equals 3 times 3, which is 9 to the 1/5. And so that's going to give me 3 to the 2/5 equals 9 to the 1/5. And we could rewrite this side as 3 to the 2/5. And so I'm going to have 3 to the 2/5 equals 3 to the 2/5. It checks out. like I said, do this very similarly with this side right here. It all works out the same. This will check out as well. I'll leave you all to do that. So you all check this one. Left to reader. They often say that in math books when they're trying to save space. Back when paper was expensive and publishing was expensive, anything that was slightly repetitive, they would just say proof left to the reader. Here we have one where it's square root. So this is definitely one where we'll want to check because we have even roots involved. But since we have an even root equal to an even root, they can only be positive. So the only time we get anything weird is if they ended up with a negative under one of these radicals, and the other one was positive for some reason like that. So we'd square this out, both sides, and we just get, probably going to check it on another sheet of paper, 10y squared plus 21y equals 6y squared plus 18. Move my 6y to the other side, 6y squared to the other side, I'm going to get 4y squared, and then I'm going to keep my plus 21y, and then I'm going to move 18, negative 18 on this side, equals 0. So now I need factors. So this one might be where you have to go out to the side somewhere and say, okay, so I need my factors of 4. So I have 4, which is 1 and 4, and 2 and 2. And then over here, my factors of 18, which are going to be 1 and 18, 2 and 9, and 3 and 6. I need some way of combining this to get this number right here. Now, one thing I might not do, or I might think about not doing, is 2 and 2. If I tried to have a 2 here and a 2 here, well, what's going to happen is that one of these numbers for 18 is always going to be even. So if it was even here and even one of these parentheses had even numbers in it, I could factor a 2 out. Notice I can't factor greatest common factor out of 2 from this. So I shouldn't be able to do it to a single factor. So one of these factors here need to have an odd and even, or an even and odd, or actually both of them need to be that. Both odd or both even. Both odd or one odd, one even. They can't both be even. Otherwise, I'd have been able to factor a 2 out here. So here, I'm going to try 4y and y. So let's try that. I'm going to try 4y. Actually, that goes there. I want to try, so I have 1 and 4. And so I need to mix those up so that their difference is 21. So I want to overshoot 21. So something that would overshoot 21 is 4 times 6, because that'll give me 24. And then 1 times 3 will give me 3, and so I'll get the difference is 21. If I make this a negative 3, I'll get positive 21. So once again, why did I go with 1 and 4 instead of 2 and 2? Is because otherwise I'd have been able to factor a 2 out of this entire polynomial before I started. So I'm going to say we have 4y, and that's going to be, and I'm going to want to pair that up with a 6, so the 6 has to be over here. I want, not paired, but I need the 4y times 6, so the 6 has to be in the other parentheses. So I'm going to have y times negative 3 here to give me my polynomial. 6 is positive. So I'm going to set each of these factors equal to 0 and solve. And so that's going to give me 4y minus 3 equals 0, or y equals 3/4. Just do that really quick. And then we have y equals negative 6. Looking at this, we want to plug this in. So this is where having a good calculator or a scientific calculator with you to check this is good. If you have a scientific calculator with 2 line input, that's really nice. The TI-30s have that, TI-30Xs. I don't have one of those with me, so I'm going to have to use this here. Also, it has a nice display screen, which I think you all can focus in on right about there. And so I'm going to say we have 10 times, and then I'm going to use my first 3 divided by 4, and oops, yep. And I'm going to want to square that. And it'll automatically square it first the way I've written it. If you're not sure, you can always put more parentheses, at least an even number of them. And then I'm going to hit enter there. So that's going to give me 26.625. I'm not going to bother to take the square root of it. I'm just going to say that this is going to happen if I plug in the 3/4. So x equals, or I should say y equals 3/4. I'm going to get the square root of 26.625. And what does that equal? Let's go on the other side. Let's say we have 6 times, and then that's going to be 4 divided by 3 squared. Oops, no, I didn't do that right. That's not right. I got ahead of myself. I got to do the other one first again. I didn't complete this out. I didn't say 21 times 4/3 or 3/4. So let me try that again. So we're going to say 10. Those of you watching this now are like, oh, I told you 2 minutes ago that wasn't going to work. 21, and then I got ahead of myself. 4. Yep. Yep. So that's 21.3. All right. That makes sense. And then we have the other one. Didn't check to see if you could see it first. And then we have, no, I have my reflection in it. We have 6 of these squared plus 18. Enter. And once again, we get the same thing. It would just be easier to leave it on. Yeah, maybe. Just be hard to see. And those both check out. I'm not going to bother to square them out, because they're both positive underneath there. And then we have the -6. So we need to check y equals -6 next. And so I'm just basically going to get, I'm going to hit, so this is something you can do with a lot of calculators. You just hit second function entry, then entry again, and you get the previous line's input. You can do that on most calculators these days. And I'm going to say -6, so it's going to be -6. Make sure you use this negative key, not the negative key down here, not the minus key. Or not the subtraction key, I should say. And then I'm going to get over here, and I'm going to say that's -6. Y'all can read that. Hit enter. So I'm going to get, oops. So I'm going to get 234 here. The square root of that is equal to, and I'm going to hit second function entry, entry again. I'm going to change this to -6. And I get 234. So both of them check out. Like I said, with the even radicals, you really need to check those. So both of these work. The odd radicals, usually not so much, because negatives can equal negatives. The even radicals, you have to be careful you don't have the positive equal a negative or something like that. I think that would only really happen, I'd have to think about the situation that happens in. Also in Hawks, you may see this problem rewritten as this minus this equals 0. So both the radicals might be on the same side. You can move to the other side. Move one of them to the other side. So now we have this exercise here, and we say the following. We have x plus 3 quantity to the 1/4 power plus 2 equals 0. And then we can say rearrange that so we get the radical on, or the rational exponent on one side. Now, right here you may have noticed something's gone wrong, but we'll keep moving just in case you haven't seen it yet. Wait until we finish, see how that happened. And then so now we have x plus 3, my 4's cancel and my exponents, and I get x plus 3 equals -2 to the 4th power is positive 16. -2 times -2 is 4, and 4 squared is 16. And so now I'm going to get x equals 13. Well, that's my only solution, so it must be the right one, correct? No, not necessarily. In this case, we may have seen right here what's going to happen is I plug 13 back in. I'm going to check, and I'm going to get 13 plus 3 to the 1/4 power plus 2 equals 0. And what happens here, I'm going to get 16 to the 1/4 power plus 2 equals 0. So in other words, I get 2 plus 2 equals 0, and that doesn't work. So this 13 didn't work. And the reason why it didn't work is because basically what you're saying here is a positive number plus a positive number equals 0. Because you can only get positive numbers back under even roots. So if you add two positive things together and you get 0 back out, that's never going to happen. So this solution had no, or this equation had no solution. It's the empty set. Like I said, one answer could work, both answers could work, none of the answers could work. Next it says, and this last one is just writing one thing in terms of the other. In a right triangle where the hypotenuse is c and the other two sides are a and b, the length of c is given by c equals the square root of a squared plus b squared. So we want to solve this formula for b. So I'm going to say c equals the square root of a squared plus b squared. I'm going to square both sides. So I'm going to get c squared equals a squared plus b squared. And typically this is how we see the formula. The two shorter sides squared, added together, and equal longest side squared. And then we're going to solve it for b by getting b on one side, c on the other. So I'm going to say, I'm going to keep b on the right hand side and just say c squared minus a squared equals b squared. And so now I'm going to get c squared minus a squared equals, and I'm going to take the square root of both sides, and I'm going to say square root of b. Now, once again, when you take the square root, you're supposed to put a plus or minus, but this says a right triangle whose two sides. That means a and b are automatically, well, should write it like that. A and b are automatically greater than 0, greater than or equal to 0. Because when it says two sides, we're talking about distance, and distance is always positive, or non-negative, I should say. So assume we're just getting the positive back out. We don't need plus or minus in front of our radical here. We don't need a plus or minus. Let me assume b is positive. Anyway, that's the lecture for today. Hope you all learned something, and have a great day.